morning, my name is Troy, and I am a grader for Engineering Practice and Graphics at UTSA. Today I wanted to go over a few 3-view drawing problems to give you guys an idea how it's done, because it'll come up in the first homework and repeatedly throughout the semester. I've even seen them on finals. But before that, I wanted to mention what a 3-view drawing problem is and why you would bother learning it. It's when you're given a isometric view, or when you're given a part and you're tasked with drawing the 3 primary views so that you can use that blueprint and the information on it, such as dimensions or tolerances or material types, to kind of convey information about the part to either the customer or the machinist. So that's essentially the whole point, is to create a blueprint to convey vital information about the part. With that out of the way, let's get to it. This is our part. In Homeworks 1, you'll be given dimensions for each of these lines, or it'll be set on a grid so that you can tell how long these lines are. I'm just going to eyeball it for convenience sake. Now, some people have this idea that they go straight to drawing. That's not exactly the best way to do it. There's a step or two before that'll help you, they'll set you up to finish the problem in a timely manner. The first step I would suggest is to identify which views you will draw and which one will be the front view. Now, given this part, each part has 6 primary views: top, bottom, and then the 4 sides. In this guy, we can easily see the top view, and then this side view, and this side view. So it makes sense that we'd want to draw those 3 views. We could try to draw the back. I wouldn't, and if you drew them correctly, I wouldn't fault you for it, but why would you make things harder for yourself? Just draw these three views. The second part of the question is which one will be your front view. And typically the front view is the view with the longest sides or with the most detail. And in this case, this would be the longest. This view would have the longest side, but you'd miss these details in here. So let's go ahead and make this the front view and denote it with an arrow. Alright, so now that we have the front view, we can see that we'll also have to draw the top view and the left side view. Now, how these views are orientated relative to the front view is important. You can't just go willy-nilly putting the top view over here, the front view right here, and the left view right here. It has to, they have to be orientated correctly with relation to the front view. The top view has to be above the front, and the left to the left side. Now, knowing that, you should take a moment and decide where you're going to put your front view so you'll have enough room for the views around it. Some people, this is where a lot of people mess up. They'll go straight to drawing the front view and they'll put it in the most logical place, the top left corner. Now this is going to be a problem later on because they'll have no room to draw the top view and the left side view, and sadly that leaves them quite in a pickle. So that's where this second step comes in: plan your view placement. So let's go ahead and put our front view right here, our top view right here, and our left side view right here. That's going to be where we're going to place our views. With that out of the way, we can go ahead and start actually drawing. Start with the front view. Now the first step to actually drawing it, or the fourth step here, is draw the surfaces you can see. So if you're standing here looking in this direction, what are the surfaces you can see? You can ask yourself that. Well, you see this rectangular shape right here. We'll just call this surface A. And back here, you can also see this very square U shape. We'll label this B. And so let's go ahead and draw those. Again, you'll be given dimensions in the homeworks, so, but I'm just going to eyeball the lengths for now. So this is surface A, and above it, right here, is surface B. Sweet. After you've drawn everything you can see, you can ask yourself, draw the surfaces you can't see. So are there any surfaces behind A and B that you can't see? And that's where you would draw the hidden lines. But in this case, the only hidden surface is this back side. That's a whole surface there. But if we were to draw that, it would be a bunch of hidden lines along the outline of what we had already drawn. And as you know, visible lines take priority. So we don't even bother drawing those hidden lines because they're hidden by the visible ones anyway. And there you have the front view. Let's go ahead and move on to the top view. Now, when looking down here, what are the surfaces we can see? We asked the same questions. Let's call this, we can see this surface, we'll call it A prime. We can see this surface back here, let's call this B prime, and let's call this C1 and C2, just for convenience sake. Those are the four surfaces we can see if we stood right here and looked straight down. Let's start with the biggest side, because it makes biggest surface, because it makes most sense. It's easiest that way. So let's line it up right above here. A quick note that'll help you especially on when we're dealing with more complicated objects. You can transfer the same widths from this bottom here. So you don't even have to measure exactly how long this line is. You just know that this surface here that we're looking down at, that's A prime. And that's A prime right here. And it'll have the same width as this A surface right here. So we can just draw it with the same width. There we go. I think I might have drawn a little short. Hang on. There, that's better. And then let's go ahead and draw C1. And then B prime. So hang on, let me label this. Let's draw C2. And there you go. Those are all the surfaces we can see when looking down from the top. Now we ask ourselves again, are there any surfaces we can't see that would be behind A prime, C1, B prime, or C2? And yes, of course, there's the bottom, but again, that hidden line would just be around the outline of this surface we've drawn, and so we can ignore that because it won't make any difference. Alright, with that all done, we can go ahead and move on to the left side view. When looking this way, we can see this big L shape here, and that's the only surface we can see. Yeah. So we'll just call this A double prime. Again, we have to line it up with the bottom of this shape with the bottom of this one. There we go. A double prime. And with all the visible surfaces drawn, which just happens to be A double prime, we can ask ourselves, what's behind it that we can't see? Are there any surfaces that are behind this shape? And of course there is. There's this guy and the side on the side right here as well. We'll call this guy D. And so if we were to draw the surface D, we'd have to do it in hidden lines because we can't actually see it. And it would go right here. These hidden lines bound the surface of D. And of course, we can't, for these hidden lines, these three hidden lines, they're under the visible line per se. And so they could be ignored. And this would be surface D. And there you go. That would be a correct